Hello friends, welcome back to our channel. So in today's session we'll see one more concept in compiler design, that too in three address code. So already in our previous sessions we are discussing about the three address code. What is a three address code and how we can write any expression into the three address code. In our previous sessions also we have seen how to write the three address code for the control structures like conditional statements as well as iterative statements. So in today's session we'll see the short circuit evaluation for a Boolean expression and how to write the three address code for such type of short circuit evaluations. So let's start the session. Short circuit evaluation for Boolean expressions. So one of the important concept. First, let us know what is a Boolean expression. So, Boolean results, you might be listening about the Boolean results, right? So, Boolean result means the result either 1 or 0, which is called as a Boolean result. Now, Boolean expression means the expression which gives the result as a 0 or 1 is called as a Boolean expression. So, simply we can say A less than B. So, this is an expression, right? This is an expression. So, expression means the group of operands and the operator. So here we are having a two operands and one operator. So this we can call it as an expression. And what is the result of this one? Either 0 or 1. That means either false or true. So this type of expressions we can call it as a Boolean expressions. Now see, even A greater than B or B greater than C, this is also a Boolean expression because the result of this one is either 0 or 1. The result of this one will be either 0 or 1, and the result of these two things will be OR operation. Again the result will be either 0 or 1. So this kind of things is also called as a Boolean expressions. Now what is meant by short circuit evaluation of Boolean expression? So this particular short circuit evaluation can be done for logical AND and logical OR operations, particularly for the logical AND and logical operations. Okay, so this short circuit expressions can be done for logical AND operation, so which can be represented with the two ampersands, and another one is logical OR operation, so which is a parallel lines. Okay, this short circuit evaluation, both are Boolean expressions. Okay, see, let us take this one first. Let us take this one. If I am writing a small syntax, so A greater than B and A greater than C. Let us take this one. Okay, let us take this one. So the complete result of this expression, so we can call this as a Boolean expression. Okay, because the result will be either 0 or 1. So the complete result of this one will be either 0 or 1. So this result depends upon the first expression and the second expression. Let us take this one as a Boolean expression 1 and Boolean expression 2. Okay, and the result between B1 and B2 will be either 0 or 1. So the result of B1 will be again 0 or 1, and again the result of B2 will be either 0 or 1, and you need to apply AND operation for these two things, which gives 0 or 1. So that you understood. Now see, what is the property of AND? What is the property of AND? So this logical AND, if the two operands are true, then only the result will be true. Okay, so you can write the truth table. Okay, for better understanding, I'm writing the truth table. So the input will be true, 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 false, false, true, and false, false. So this is for AND. This is for AND. So what is the result of this one? So if both are true, it will be true. True, false, it's false. False, true, it's false. False. So you can see, if one of the input is false, the result is false. If one of the input is false, the result is false. Now, if B1 is false, the result will be false. If B2 is false, result will be false. Now, what is meant by short circuit evaluation? That means if you compute this b1, if the result of b1 is 0, that means if it is false, okay, if it is false, you see, if any one of the input is false, the result is false. So if the input of b1 is false, I mean the output of b1 is false, you need not compute the b2, because one is false among these two, the result will be false. So the result will be always false. If the b1 result is 1, now the result depends upon b2. So b2 should be computed, because if b2 is 1, the result will be 1. If b2 is false, the result will be false. So the complete result of this expression, this kind of expression, the complete result of this kind of expression depends on b1. If b1 is false, b2 can't be computed. If b1 is true, then only b2 can be computed. So if b1 is false, b2 need not be computed or evaluated. If b1 is true, so b2 should be computed, that means evaluated. So this is called as a short circuit evaluation. So here logically, and that evaluation always done from left to right. So this thing can be evaluated from left to right. So in both the cases, AND and OR. So this explanation is completely with the logical AND, and the same thing applies for logical OR also. See, I'll give you, if it is a logical OR, so the same thing, if you write a greater than b or a greater than c, okay, so this is a b1 and this is a b2. So what's it? Okay, I'll once again I'll write here OR operation. So t t t f f t f n f, and the result will be true, 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 false. So you can observe here, if any one of the input is true, the result becomes true. If both the inputs are false, then the result is false. Here, if b1 is true, then automatically you need not compute b2, so the result will be true. Okay, and if b1 is false, then b2 should be computed, because the result of whole expression will be depending upon this one. Okay, if b1 is false, the whole expression will be depending upon the result of b2. So if b2 is true, the result will be true, and if it is false, the result will be false. Okay, so mainly this kind of thing we call it as a short circuit evaluation. It always done with a left to right, and it will be evaluated for logical AND and logical OR, particularly logical AND and logical OR. So it depends upon the first expression, and the result of, based on the result of first expression, the second expression will be evaluated. Okay, now we will see one example, and we will write the 3 address code for this particular short circuit evaluation by using this short circuit evaluation. Okay, so example, for both cases we can see. So I'll write the same thing. If a greater than b and a greater than c, let us take some x equal to 0 and else x equal to 1. So let us take this example. The three address code for this one. Okay, the 3 address code for this one will be, so this is not a iterative statement, so we need not start with the label. So first check this particular expression. If a greater than b, if it is true, this can't be executed. Okay, this can't be computed, need not be computed, directly you can go here. So simply write go to L1. If it is false, then it should be executed. Okay, if it is false, it should be executed. So simply you can go to L2. Okay, go to L2. So here you can write L1, L1, okay, L1 as, go to L1 means x equal to 0. Okay, and again go to some L4. And L2, what is a L2? If this is false, it should be computed, because sorry, if it is true, okay, if it is true, I'm extremely sorry, if it is true, then it should be evaluated. Okay, it should be evaluated. If it is false, the complete expression is a false, right? So if it is true, then go to L1. L1 will be this, it should be computed here. Okay, if a greater than c, okay, go to L3, else go to L2. So what is a L2? If this is false, the complete expression is false, so automatically it should be executed. L2 is x equal to 1. Okay, so what is a L3? If this becomes true, okay, this becomes true, go to L2. Here it is L3, right? If this is also true, yes, sorry, yeah, go to L2. And L3 means if this is true and this is true, okay, this is true and this is true, then x equal to 0. Simply you can skip the else part. So go to L4, go to L4. And here also, if it is false, then else, yes, this one. Okay, I'll write here, you can write here L2 x equal to 1, L4, right, simply. So you can see, once again, just think a greater than b. If it is true, then you need to evaluate this one. So go to L1, it will be evaluated. And if it is also true, this should be executed. Go to L3, so here, and immediately after this it should skip and it will be L4. So directly it comes here out of the conditional statements. And if it is false, so directly this should be executed and L4 here, so directly it comes here. If it is true, okay, and if it is false, and here also it is L4, directly it comes here. Yes, so this is a simple 3 address code for this particular short circuit evaluation of a conditional statement and logical OR. So hope you understood. Okay, now same thing we can apply for OR. Same thing we can apply for OR. So here there will be a lot of confusion among giving the labels. Okay, among giving the labels. So as of now, just understand, try to understand this one, and these kind of problems we can solve by using a one more concept called a backpatching. So that we'll see in our further session. Okay, how can we manage the labels for a conditional and unconditional jumps? Okay, yes. So for this example, let us take if a greater than b, if it is true, what should be executed? This cannot be evaluated directly, this can be done, right? So go to L1, okay, go to L1. And if it is false, okay, it should be executed. So once again we can write, if a greater than c, if it is a false, this will be executed, right? So if it is true, again go to L1, go to L1. If it is false, go to L2. So what is a L1 here? L1 means if this is true, or means if any one of the input is true, the result will be true. So this should be executed. So x equal to 0 and L2, and it should skip this one. So here once again we need to give a label. I'll wait for the label. And if this is false, this will be executed because this is a false case. So if it is also false, go to L2. That means this one, x equal to 1, x equal to 1. So immediately we can write L3. So go to L3. Okay, simple. So if you understand the flow control of, the control flow of execution, so simply you can write the 3 address code for all these things. So once again, let us check whether it is right or wrong. So if this is true, this is a OR, so you need not compute this one, directly this will be executed. So if a greater than b, if it is true, go to L1, L1 is x equal to 0, and you need to skip this and come out from this one. So we are writing go to L3, so directly it comes here. And if it is false, this should be computed. So if this is false, this should be computed. So again, if a greater than c, go to L1. That means if this is true, okay, this case means a greater than b is false and a greater than c is true, then go to L1. So same thing. If again this is also false, go to L2. That means this part will be executed. Go to L2 and directly L3, right? So this is the short circuit evaluation for Boolean expressions. So mainly this short circuit evaluations will be applied for a logical AND and logical OR, because here we are comparing two different Boolean expressions. So the result will depends upon either one of the Boolean expressions. Okay, so this is the 3 address code generated for the simple Boolean expression here. Okay, I'll stop here, and if you are having any doubts regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. And if you really enjoyed the session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.